Okay, one more quick mechanism day. Quiz 13, write a mechanism for the reaction of ethanoyl bromide with phenol. So this is an alcoholysis, one of the things I have the most trouble pronouncing because I don't slow down. I expect it to be as natural as hydrolysis. But the alcoholysis is, we got the ethanoyl, means there's two carbons with carbonyl on it. There's our ethanoyl, carbonyl, two carbons, and then there's a bromine on there. So we did a lot of reactions with methanoyl chloride, ethanoyl chloride. You just substitute bromide for chloride, bam, same thing. Remember, this is subject to substitution with carbonyl if you have water or an alcohol or something along those lines. Phenol is phenyl alcohol. So this part of the organic chemistry is just knowing what the different compounds are. So remember when we did the acids, I asked you to memorize a whole bunch of simple compounds and their pKa's, and if you did memorize those simple compounds, you don't have to guess as to what the reactants are. You just know what phenol is and know what substituted phenols would look like. So now we have the classic reaction of an OH or NH group with carbonyl. So that goes in 3 steps. First, the phenol acts as a nucleophile. Bam, electron pair attacks the carbonyl. Almost forgot some valence electrons here. But as this attacks the carbonyl, it's going to add some electrons, so we're going to have to push some off to make room to obey the octet rule. When that happens, we get what I keep calling the famous tetrahedral intermediate, where this carbon now has 3 things on it: the methyl that's along for the ride, the oxygen from the carbonyl, the bromide that hasn't quite left yet, but you know that's what's going to happen, and now the phenol. Right? So there we go with the tetrahedral intermediate. And then the next thing that happens is we go this way and the leaving group leaves, and that leaves some room for the carbonyl to reform. So the methyl's along for the ride. The carbon has now reformed the carbonyl, and then the phenol is all stuck on there with its hydrogen and its lone pair, and this phenol has got a formal positive charge on the oxygen. So when we came in, we had 2 things that were neutral. We have to overall be neutral here, so if there's a negative up here, there's got to be a positive somewhere. If you check the formal charge of this oxygen, 1, 2, 3, 4, 5 electrons assigned to it, it is positive. And so this guy is going to be deprotonated. So the bromide that's kicked off in the second reaction, when the leaving group leaves, can go ahead, grab the very acidic hydrogen, making this bonding pair a lone pair, and that'll give us our awesome final product. The methyl is along for the ride. The carbonyl has been reformed. Yay, carbonyl. Now the oxygen, 2 lone pairs, and the phenyl on it. And we've regenerated some hydrogen bromide that was probably used to make that acid bromide in the first place. But there we go. We have this ester, which looks like it's phenyl ethanoate. So when we have the carbonyl attached to this oxygen, that looks like a deprotonated ethanoic acid, or ethanoate, with the phenyl on it. So phenyl ethanoate awesome name. So there we go. Simple mechanism, relatively. Attack of the nucleophile on the carbonyl of the acid bromide to give the famous tetrahedral intermediate. Then the leaving group leaves, reforming the carbonyl, and then the leaving group can go ahead and deprotonate the phenol part of the molecule. And this arrow doesn't look very clean and tidy, so if I were reviewing this, I might say, okay, this pair of electrons needs to go as a lone pair to the oxygen, and when that happens, then we get, when we deprotonate the intermediate, we get the final product. So super nice, 3 steps. We've seen very similar steps like this before with water, alcohols, or amides reacting with acid halides such as chlorides and bromides. Hopefully you've got it. Good job if you did, and do a little more studying or ask some questions, watch the videos again, practice these guys, because with repetition you get darn good at it.